Hi, everybody. Welcome back. So last time we had talked about working with, or one of the priorities of using the pipe operator, and that was to build pipelines. And then we gave some examples of the filter function and how the filter function can be used to drill down to sections of rows or sections of records in our spreadsheet. Um, and again, when I say spreadsheet, I do mean data frame or tibble, basically just our studios or R in our studio's representation of rectangular data, where the samples are on the rows and the features are on the columns. So we understand that the filter function, we're inside of this conversation about dplyr and the tools that we have for working with tibbles and data frames. And the filter function allows us to get at subsets of rows that meet a certain criteria. So this harkened back to our idea of Boolean subsetting or logical subsetting or relational subsetting, where we build a vector of trues and falses. So if we have a data set of 337,000 rows, then we would build a vector of 300, roughly 337,000 trues and falses based on some condition, and then subset to the rows where that condition was true. And we can um, make very complex chains of decisions, chains of logic. And that was all inside of the filter function. So if you needed a refresher on the logic, there's some material back in the atomic vectors and the lists and tibbles chapters. Go back through and look through those sections on relational subsetting and Boolean subsetting, logical subsetting, because the filter function is just doing the exact same thing again, and in perhaps a little bit cleaner form. So right now, we're going to work on understanding what the arrange function does. It's not terribly challenging. And then we'll move right into working with the select function, which will allow us to reorder columns in our tibble. So the arrange function is going to do exactly what you think it's going to do. It is going to sort the data. It is going to arrange the rows of the data. And by default, it will arrange in increasing order. So if we arrange on the year, the month, and the day, this data set, it's going to put the first month first, then the first day first. So we're going to start our record, we're going to start our records January 1st, and then the end of the table, the bottom of the table, row 336,776, will be some flight from December 31st. So we're starting at the top of the year, going to the bottom of the year. And what's important here is to note that we have the month sorting before the day is sorting. So the order that you supply the arguments here is the order of the arrangement. So we're going to first sort the month, and then within the month, we're going to sort the day, because we don't want to have all of the firsts of the months together. So we're like January 1st, then February 1st, March 1st, etc. And then after that, we would get to January 2nd, February 2nd, March 2nd, April 2nd. That doesn't make a whole lot of sense. So we're going to make sure that the month is supplied first, then the day. So sort on the month first, then the day. If you need to reverse that order, you can use the DESC for descending. So say I want to arrange on this column, but I want it to be done descending. So the descending function is a helper function that's going to change how the arrange function operates, and it's going to reverse the order of the sort. So this one right here, we're finding departure time, or I'm sorry, departure delay, and we're reversing this order. So the flight with the longest departure delay happened to be on January 9th. And it's a heck of a departure delay right there. So, and this is also again stepping into the whole point of this is we're adding little tools to our tool belt, so we understand how to select rows with filter, and we understand how to sort rows with arrange. Now we can combine them, okay? And we're using the pipe operator again to combine multiple operations. So right here we say, okay, well, do we want all of the American Airlines flights out of JFK the day before Thanksgiving, um, And so what this is going to require me to do, I'm going to have some domain knowledge. So if you remember, data science is we've got our three pillars. We've got our code pillar, we've got our math and stats pillar, and we've got our domain knowledge pillar. So I need to be able to know metadata about the data to know that American Airlines is abbreviated AA, that John F. Kennedy Airport is abbreviated JFK, that in 2013 Thanksgiving was on the 28th. So now I know that the day before Thanksgiving is the 27th. All right. And so I need this information ahead of time. And that information is not included in the data set itself. It's meta information. It's information about the information. And so my first step is take the flights data set and then drill down or filter to all the flights that came from American Airlines. And then drill down to all the flights that came from JFK. And then drill down to all of the flights that happened in November. And then drill down to all the flights that happened on the 27th. So notice that because we've already said, give me all the flights in November, these are not all of the flights from January 27th, February 27th, March 27th, et cetera, et cetera, et cetera. These are only going to be the flights that are from November 27th. And then finally, so this is our final, and then I want you to give me all of the flights that have the longest delay. So it looks like right here, we've got or I'm sorry, oh, not delay, the arrival, the air time. Give me all of the shortest flights. So the air time, this is the time in the air, and find me all of the shortest flights for whatever reason. And we would say, okay, these are the shortest flights the day before Thanksgiving. But you see here, we have built a pipeline. Okay. Now in this pipeline, we can change out different components, but the general idea is that once you have an understanding of what's in your data and you are able to write these commands, you can reuse these commands with the exact same code or with slight modifications, and you don't have to start from scratch every single time. Okay. It allows you to do a lot of powerful things once you're used to the idea of writing the script. You can reuse pipelines and you maybe change the data set if you have another data set. So if we have NYC flights 14, okay, then we would just say, okay, I have all of this pipeline. This pipeline is the same. The pipeline's the exact same. The only thing that changes is that my flights data changes from 2013 to 2014, and I would perhaps need to update this. I would need to change the date from the 27th to whatever the day before Thanksgiving was in 2014. But the rest of the code, I don't have to retype this. Okay. So when you're working with public health data, it's often a very good idea to build out pipelines that are easy to modify because we're going to get another set of census data every 5 years and every 10 years. We're going to get a yearly survey data from the different institutes within the NIH, from the CDC, from different branches within the Department of Health and Human Services, from different state level data. We've got health data that comes out from the states on county level, at census tract level, at zip code level every year. So if you write your code in a certain way so that it is flexible, then when the next set of data comes in the next year, you don't have to start over from scratch. And that's very important. We're working on a project right now that we're connecting databases all related to individuals who are HIV positive throughout the state of Florida. And we're looking at data is going to be coming in. We've got data over the past 5 years, and we've got funding for the next 5 years, so that every year we get a new set of data. But we're not going to be rewriting code from scratch every January and February whenever we get access to the data. We have data, or we have code that we've already written, and we've got it well documented, got lots of great comments. We've got the file names saved where they need to be saved, and we'll be able to just apply those functions to the next set of data with very minimal modifications. All right. So again, right here, as an aside, look how clean this code is because of our pipes. and we get to just reuse functionality over and over and over again. Okay, I'm actually gonna, I spent a little bit longer talking about that than I was anticipating, but that's okay. I'm gonna pause here and we're gonna pick back up with select, which will be reordering columns. So see you soon.